Hi, good morning everyone. My name is Logan Raj Analilaki Munisami. My metric number is b042210122. Okay, now I'm going to explain about our article. We chose an article about steam power plant. This study analyzes a steam power plant with double reheat and 6 feed water heaters to optimize efficiency. The plant operates on the Rankine cycle, converting thermal energy to mechanical and electrical energy. Key components include boiler, turbines, condenser, and pumps. Double reheat and feed water heaters improve thermal efficiency by maintaining steam temperature and preheating water, reducing fuel consumption and emissions. By evaluating energy and exergy efficiency, the study identified areas for improvement aiming to enhance performance and sustainability, contributing to more efficient and environmentally friendly power generation. Now, I'm going to explain about the schematic drawing. Actually, there got two types of schematic drawing. The first one is the real schematic drawing with the specified elements. The second one is simple schematic drawing, so the viewers can understand easily. The schematic represent a regenerative Rankine cycle using thermal power plants to improve efficiency. The process starts with cold water entering the condenser where steam from low pressure turbines condenses. The condenser is pumped through a series of low pressure heaters heated by extracted steam to remove dissolved gases in the radiator. The feed water pump then increases water pressure for high pressure heaters which preheat the water before it enters the boiler. In the boiler, the water is converted to high pressure steam which expands through the high pressure, intermediate pressure and low pressure turbines for generating mechanical work. Extracted steam from the turbines heats the feed water, improving overall efficiency. The cycle repeats as the remaining steam returns to the condenser. I'm going to explain the work did by boiler, high pressure turbine, intermediate and low pressure turbines, condenser, feed water heaters, radiator, feed water pump and condensate extraction pump in thermal power plants. For the boiler, it heats water to generate high pressure steam. For the high pressure turbine, the pressure steam expands producing mechanical work. For the intermediate and low pressure turbines, the steam undergoes for further expansion and reheating stages to extract additional work. For the condenser, it converts the exhaust steam from the turbines back into water by removing heat. For heat water heaters, it preheats the water using steam extracted from various stages of the turbine, thus improving overall efficiency. For the radiator, it removes dissolved gases, the feed water to prevent corrosion. For the feed water pump, it increases pressure for feed water to the level required by the boiler. For the condensate extraction pump, it transfers the condensate water back to the feed water system.
Assalamualaikum, my name is Afina Batusha binti Yusri. My matrix number is b042210113. I will present about method of performance analysis. First step is energy analysis. So apply the first law of the thermodynamics. Perform energy balance calculation for each component of the cycle, which is boiler, turbine, condenser, feed water heater, radiator, feed water pump, and condensate extraction pump. So we need to calculate thermal efficiency. Determine the thermal efficiency of the cycle using the ratio of net work output to heat input. This is formula work net divided by Q in. So we need to consider the energy inputs heat added by the boiler and output work done by the turbine and pumps. Second is exergy analysis. First, we need to apply the second law of thermodynamics, assess the quality of energy transformation within each component. Then we need to calculate exergy destruction and efficiency. Determine the exergy destruction rate for each component by applying exergy balance equation. Calculate the exergy efficiency using this formula. Exergy output divided by exergy input. So identify exergy degradations, pinpoint where significant energy degradation occurs within the cycle. Propose potential improvement to reduce exergy destruction and exchange efficiency. First step is parametric study. First is investigate impact of key parameters. Second is very critical parameters such as condenser pressure, boiler is steam temperature, and turbine extraction pressure. So condenser pressure is analyzed how change in condenser pressure affect the overall system performance, including boiler, heat load, and turbine power output. The second one is boiler is steam temperature. Examine the influence of different boiler is steam temperatures on cycle efficiency. The third is turbine extraction pressures. Evaluate the impact of varying extraction pressure on the performance or high, intermediate, and low pressure turbines. That's all for me. I will give next to another presenter. Assalamualaikum. My name is Afina Batusha binti Yusri.
Okay, hi, my name is Muhammad Mirfami bin Jasni and I will be explaining about the calculation based on our journal. Alright, first of all, the first law of thermodynamics can help us determine the thermal efficiency of our power cycle. So the equation for the thermal efficiency is the work output W over the heat input Q in. To find the total turbine work output, we need to find the work for the high pressure, intermediate pressure, and low pressure turbine. So the mass flow rate times the high pressure enthalpy at point 12 minus 14. For the intermediate pressure, enthalpy is at 15 minus 17, and for the low pressure, enthalpy is at 18 minus 20. And then we got total of 650 kilojoule. Next, to find the heat input or Q in, it is mass flow rate times the enthalpy at point 11 minus enthalpy at point 10. So we got 2385. Then to find the thermal efficiency is 650 over 2385. Then we got the 27.3% for the thermal efficiency. Next, for the second law of thermodynamics or SG, it is to measure the ratio of useful work output to the total SG input. Then for the formula of SG efficiency is W turbine over the SG input. To find the SG input, the mass flow rate times psi at point 11 minus psi at point 10. So we got 1793.251. And for the W turbine, we use the previous value is 650 kilojoule. So the SG efficiency is 60 over 1293.251. And then we got 36.2%. Alright, I think that's all from me. Thank you.
Hi, my name is Sopa Carmila Betty Shamsi. My matrix numbers is b042210080. For my point is suggestion of system improvement. First, optimize extraction pressure. Like high pressure turbine stage, determine the optimal extraction. Intermediate and low pressure turbine stage, evaluate and adjust the extraction pressure. Second, adjust boiler exit steam temperature, increase steam temperature, raise the boiler exit steam temperature. Material consideration, ensure that material used in the boiler. Third, control condenser pressure, lower condenser pressure, reduce the condenser pressure. Advanced cooling technologies, utilize advanced cooling system. Fourth, implement advanced heat exchange, efficient feed water heater, upgrade to more efficient feed water, enhance condenser, improve the design and operation of condenser, deaerator and heater optimization, optimize the performance of the deaerator. For conclusion, in this study, a thermodynamic analysis of a reheat Rankine cycle steam power plant with 3 HP feed water heaters and 3 LP feed water heaters with deaerator is conducted. In terms of first law of thermodynamic analysis and the second law thermodynamic analysis, the main conclusions drawn from the present study are summarized as follows.